Hello, welcome to the Fulani Show. I'm Dr. Lenora Fulani. Joining me is my co-host, Dr. Fred Newman. Our guest today is deGrasse Tyson. Mr. Tyson is the new director of the Hayden Planetarium. He's also a member of the Astrophysics Department at Princeton University. A scholar and educator, as well as a scientist, Mr. Tyson is the author of several popular books on science, including Merlin's Tour of the Universe and Universe Down to Earth. Welcome, Neil.
Great to be here. Thanks for inviting me.
We're thrilled to have you. Why don't we begin with you telling us what the importance of astrophysics is to everyday people?
Well, I'm not going to fool you into thinking that what I do puts food on somebody's plate who's in the street. That's not what's going on in the universe. But there's something different that we can tell you. For example, our understanding of sort of our place in the world, in the universe, is what is drawn from the research into outer space. So, for example, when Copernicus put the sun back in the center of the known world, all of a sudden Earth was no longer this sort of special, singular place. We were one of many planets in a family of planets in what we then called a solar system. And so the study of the universe gives us perspective that you would not otherwise have. When I look at the maps and I see wars breaking out all over the world, I wonder what's going on in the minds of those people who fight across these boundaries on this little speck of dirt we call Earth. And so I think there's a cosmic perspective that studying the universe can bring that can, in fact, lift you above a lot of what people think are major issues and problems, when in fact, if you know, can we all get along? it's a common thought. It's a big question. And when I look at the Earth, I don't see countries. I see land masses, and when I step back, I see just one fragile place that we call Earth. And I think that perspective is important, and not enough people have it.
How did you end up in this field? Like, what inspired you? Well,
believe it or not, it started in the Bronx.
The Bronx.
the Bronx. I was on a street corner. I was 10 or 11 years old, and there was a friend of mine who had a pair of binoculars, and he invited me to look up with them. Now, I had looked through binoculars before, but never up. You know, in people's windows or sporting events or whatever, but I never looked up. And the moon was there in the evening sky, and I remember it was a first quarter moon where shadows are very long on the mountainsides at the boundary between light and dark on the surface of the moon. And I pulled up the binoculars, and the moon wasn't just bigger through the binoculars, it was better. There were mountains and valleys and craters, and it all seemed to come to life. And it was all of a sudden not just this orb floating in the sky, it was a place that we might even go, a place that told me that if this is our closest neighbor, what kind of places go beyond that? What kind of planets are out there? What kind of galaxies? What's going on in the universe? And a simple pair of binoculars did this for me. And from then on I said, if binoculars can do this, what would telescopes do at the tops of mountains? And I was on that, I set forth I was a boy with a mission, becoming a man with a mission in my later years. And so I've been rather focused ever since.
You know, there's a tendency on many people's parts, I think, to think that astronomical phenomena are relatively fixed, that there aren't major changes in theories, but of course that's not true. So what's going on? What are the current significant and important happenings in the astronomical sciences?
Well, let me set a few records straight. First, there's some basic laws of physics, gravitation, quantum mechanics, this sort of thing. Those are time-tested, and they're not changing day to day. We can discover new things by invoking those principles that plug in, and we can expand our knowledge of the universe through these channels, but we're not flipping our understanding of quantum mechanics or gravitation or electromagnetism daily. That's not happening. What is happening is you take these basic laws of physics and you construct a model of how you think something ought to be. Or you'll classify something based on certain knowledge that you've acquired. And a good example of that is what do we do with Pluto now? Pluto, we all grew up knowing is the 11th, excuse me, 11th, as the ninth planet in the solar system, the farthest one out. And new scholarship has shown that there are other objects in the solar system that look more like Pluto than either object looks like any of the rest of the planets. So all of a sudden, we look back on how we've classified the planets and said, well, maybe Pluto is not a planet, maybe it's this other object that's out there. Before these other objects were discovered, it was a singular thing. We didn't quite know how to classify it. We called it a planet just to be charitable to it, really. But it was smaller than all the other planets, smaller than Earth's moon. It's, you know, it's a really feeble example of a planet. And so we always knew it didn't quite fit in. Now we found a whole family of objects that it would now belong to. So in that sense, ideas move forward. We come to deeper understandings of how things work. And the deeper understanding, more often than not, takes what we knew before and embeds it in a larger picture. And we say, that's true in this context, but in fact there's a bigger story going on out there. And that bigger story tells us much more about how the universe works than what we understood to be true previously. So there's a lot going on in our understanding of solar systems. We're discovering new planets beyond our own in our solar system. In fact, we now know more planets outside of our solar system than inside of the solar system. And that happened this decade, in the last 2 years. And before this decade, we knew of no other planets outside of the sun's 8 or 9. And so the field is moving very quickly. There's new evidence about what powers the centers of galaxies, supermassive black holes. And by the way, a lot of these new data come from the Hubble Space Telescope. New technology brings in new data and enables you to tune and sharpen your previous theories or open up whole new ways of thinking about the world that you had never even thought of before. So the ideas are moving in tandem with the development of technology, and not only the hardware side, but also the software side. The fact that we have bigger telescopes bringing more data than ever before. What good is data unless you can interpret it and find ways to analyze it? And in that regard, we need the power of supercomputers in tandem with the construction of large telescopes to decode the nature of the universe. And that's what keeps me off the streets every day.
Are you involved in, I don't know, basic research around this? Do you mostly teach? What's your relationship to the discovery?
Right at this moment, most of my time is engaged in rebuilding the New Hayden Planetarium. But when that's built, and what I was doing before then, it was about 50-50. Half of my effort was conducting research at the crest of what our understanding is, in my particular case, of the structure of our galaxy, the Milky Way. In the nighttime sky, you look up and you see the Milky Way above you, but in fact, we're in it. So it's not this other thing, it is us. It is our galaxy, the Milky Way. And much of my research concerned the structure of the structure and content of the Milky Way galaxy towards the center of the system. But in addition to that, I write a few columns, one for Natural History magazine, which is one of the most fun things I can do because it reaches a very broad audience, and the challenges of laying down words and sentences that can hold someone's attention from beginning to end. It's not like a movie where you pay your ticket and if there's a boring part, you're in your seat. You're going to make it through that boring part to get to the exciting part. In the written word, to do it right and I think to do it well, you have to put a level of thought into what's going on in the mind of the reader and where are they thinking versus what you're telling them. And it's my way of sort of sharing my excitement for the universe with the general public.
I've mentioned, we were talking before, that some of my background is in the foundations of mathematics. And I'm just recently reading a book about the famous mathematician and logician Kurt Gödel. And I read a quote from Gödel, it really struck me, which relates to what I want to ask you about. Gödel was writing this essay in the 1950s, 54 maybe, and he said, he was commenting on the fact that he just recently had seen an essay about his work in pure mathematics, which was being used to discuss spirituality. And that he comments that he didn't find that surprising because in some respects his work is connected to spirituality. How do you see that connection, or do you see that connection? I know some people do, in your work. Is there a relationship between the way we talk about the cosmic, the astronomical, and spirituality? For some people, there's a strong connection. How does that feel?
It depends on how you want to sort of slice the usage of the terms
Yeah.
in that question. Let me slice it two ways and respond on both sides of that fence. One is spirituality in the way it's normally described and discussed plays essentially no role in the discovery of astrophysical physical phenomenon, in the sense that there is no discovery that was made where someone invoked a spiritual force or insight into some problem. That's just never happened ever. Okay, so in the history of science, the methods that have developed, had that been successful, we'd be doing that today, but it's not. It just hasn't been. Now, given that, there are people who are driven in their scientific pursuits by very deep philosophical, one might even say spiritual, a spiritual energy for what they do. Mm-hmm. Einstein was such a person. Mm-hmm. And so one could argue that the energy level one exhibits for their work is spiritually driven, and it's why why they'll forget to go to sleep, because they're working on a problem that is so engaging. Mm-hmm. That level of engagement is operating on your mind, body, soul in ways that some other walks of life don't. So I can't deny the role of the usage of that word in that context. Yeah. But I can tell you that the general usage of the word spiritual, which often invokes religion or religious teachings, there has been no religious teaching that has a content that you can say, let's take that and use that to learn more about how the universe works. That just has never happened. In fact, the opposite has happened. Anytime that's been invoked, science has been delayed or set back. And so, so the methods of science are not spiritual in principle, they're experimental. And so it's how we've moved forward over these centuries. Mm-hmm. Mm-hmm. And by the way, it didn't come, that was not a first thought to people. It took thousands of years to come up with these methods. Yeah. And you can credit most of the technology you see in the world around us, good or bad, to the successful application of these methods of science.
Mm-hmm. So you talked before about the Copernican revolution, for example. So I guess there are some people who might suggest, and I'm not advocating this, but who might suggest that there was a shifting sense of who human beings were, which came at least as early as the actual discovery of where the Earth was relative to the Sun. Which comes first, I guess? Yeah, did the humanistic conception come first, or the scientific conception later? Or
there's a lot of talk about the social conditions at the time that prevail at the time a scientific discovery is made. Yeah. I think connections are made beyond what could be really supported by actual data. And what I mean by that is there are times where you could point to social unrest or social enlightenment where there didn't happen to be a tandem scientific discovery. So if one happens to coincide, to say that there was a cause and effect rather than just coincidence, I think it was unwarranted. Mm-hmm. So maybe in some cases, but there are so many counterexamples one could draw that I don't read too much into that.
Right.
Right. I wanted to go back to Pluto. I read your article in the New York Times. What do you think are the ramifications or are there any, for this new discovery or change in, because it was the topic of this article that was in the Times relative to how people were going to feel about Pluto no longer being a planet, people growing up with it there.
Well, let me give a 30-second background on this. Mm-hmm. Pluto was discovered in 1930. It's the only planet discovered this century. And immediately people suspected that it was a peculiar beast. Like I said, it wasn't as big as the other planets. It wasn't, everything about it was peculiar. Had, peculiar written all over it. And given that, people didn't quite know how to make it join the family of the rest of the planets, but we had no other way to think about it. So we said, fine, come on in. Beginning in the 1980s, if you started looking at astrophysics textbooks, Pluto was lifted out of the planet section and put into another chapter mixed in with the comets and the asteroids. So we were already recognizing that Pluto was a something else left over in the solar system that never made it as part of a planet. So we're headed there. And then with the discovery of other objects that were frozen ice balls, just like what Pluto is, we said, that's what Pluto belongs to. And yeah, you know, when you're a kid, and you know, Pluto's almost everybody's favorite planet. You know, there's a Disney character, the dog, which by the way was invented the same year that the planet Pluto was discovered. And you know, and I've taken informal surveys in the dome of the Sky Theater, and you know, you do a planet tour, and then you know, we get to Mercury, Venus, Earth, Mars, Jupiter, Saturn, and what planet is next? You know, Pluto, and everyone is screaming, and they love it. And to say now it's not, no, but the way I'd like to look at it is, the way Pluto formerly was, it was the pipsqueak of the planets, but now it may very well be the largest of this new class of object. And so why not revel in the fact that it can now be considered the biggest of its kind rather than the smallest of another kind? And so I think Pluto's happy. I don't think.
But there's no spirituality involved in it.
No. But it's a ball of ice. It's a ball of ice. You know, there's no. You can pray upon it, but it ain't gonna change a damn thing. You know, it's just what it is.
Absolutely.
You know, when I was a kid in the Bronx, growing up in the Bronx, also the most exciting visit that we ever took was the one to the Hayden Planetarium.
Oh, no question about it.
Standout.
No question about it. To this day, my first night sky was the dome of the Hayden Planetarium.
Right.
In fact, so you don't want to hear an embarrassing urban thing. When I go to these mountaintops I was telling you about to view the stars, and I look up and I see the night sky, I don't think, gee, look how beautiful the universe is from a mountaintop. I say, this looks just like the Hayden Planetarium. It's embarrassing, but it's true. It's what. Don't tell anybody. Right?
Sure, we'll keep that quiet.
That's right.
So is the newer one that's being under construction?
Yeah, yeah. In fact, what we're trying to do is we're recognizing that the field is moving so fast that if all you were equipped with was simply a dome to project stars upon it, then you're going to move backwards just by standing still. And what we've done is completely redesign the facility to equip it with the capacity to stay current with all of the latest discoveries that we have. Do you realize that when the original Hayden was conceived, designed, and built, that was before, it was conceived and designed before we even knew that there were other galaxies beyond our own. There were these fuzzy things in the sky, and everyone said, oh, they're just fuzzy things, when in fact they were entire systems of stars, hundreds of billions of stars outside of our own. Black holes, quasars, the expanding universe, whole branches of astrophysics did not exist then. But back then people felt, well, the night sky, that's pretty much all you need. We can show some eclipses and show some what the sky looks like from Argentina, wherever you want to go on your trip, and that got you pretty far back then. But in the service of the museum going public, it's our mission to serve the science and education of what the subject demands. And in this new facility, yes, we will, of course, there's a Sky Theater in this facility, but it's much more than that. There's a whole hall of the universe. We have a room that we're building that will recreate the first 3 minutes of the Big Bang. So you walk through there, and it's an immersive cauldron of matter and energy. And after you sign a release before you walk. And so there are like I said, whole branches of astrophysics that we now have an opportunity to tell the story of. Another thing, for example, the very material that makes up your bones and muscles, the carbon and the oxygen and the nitrogen, all of those elements were forged in the centers of stars that then blew up and spread their guts all over the galaxy to make those heavy elements available to form planets, people, and all the things that we know and love on the surface of this Earth. That was realized in the 1940s and 1950s, which is a full 20, 30 years after the original Hayden was built, for example. So a major part of the stories we'll be telling include these things that have happened since then. And by the way, I did this experiment at the Princeton Library. If you look at the Princeton Astrophysics Library, if you look at the research journals on the wall, and you count backwards from modern day and find the midway point of all the researched literature on astrophysics, the midway point is 1985.
Wow.
In the full history of time, 1985. So the field is moving fast. And so one of the major elements of the new facility will be Yes, we'll have exhibits that convey the fundamentals of the subject. But the late-breaking news, no, we don't want to design an exhibit that only presents the late-breaking news, because then it could be out of date in a few weeks, and that's just not a wise way to spend your money. So we have the fundamental exhibit, and then we have ways to plug into that exhibit where we do bring in live feeds from the latest results from Hubble, from NASA, from the Jet Propulsion Labs, and in that way you have the sort of the science candy, you know, the latest discoveries that are going on, plugged in the context of the history of the fundamentals of the subject. And in that way, the science literacy can be measured not by how many facts you can recite when you go home, but how much you can actually understand about how the universe works. And these are major elements, pedagogical elements we're infusing into the facility.
Speaking of these pedagogical elements, I know you have thoughts about how astronomy and the sciences more generally are taught in the school system. How does that?
Well, it's basically not.
It's not.
Which I'm only semi-opinionated on. I mean, what do they teach? They teach earth science and you know, chemistry and biology. You see a lot of that even as early as junior high school, but you don't see the study of the universe. And in modern times, it's basically astrophysics, is what you call it. You don't see that, and I think that's unfortunate, only because discoveries in astrophysics make headlines. I've got at home a stack of all the Time and Newsweek magazines where something that was discovered by colleagues of mine made the cover story. The cover story. And so there's a thirst and an interest. If I tell you that there's a black hole in the center of our galaxy, there's a story about that in the Tuesday Science Times or in the and the excitement that brings and the gorgeous imagery that comes back from Hubble tells me that there's a thirst for the subject of astrophysics that has not been tapped to the advantage of the educational system. Because if you want to attract someone to science, to become scientists, you need something you need a hook, and you need a hook that works. And if showing beautiful pictures of the universe is a hook that works, then do it. And by the way, it's not that there aren't exciting things in chemistry or biology or earth science. I'm not denying that they've also got cool things, but if you just look at what's sort of naturally hitting the cover stories, I think astrophysics has a long way to go to reach into the school system. Yeah.
Isn't it also true that, at least I'm speaking as a lay scientist now, obviously, my impression though in reading about science, and I read a great deal about it, is that a great deal of contemporary science in all areas comes out of discoveries in astrophysics and so on, but it's not projected that way in
No, it's not. In fact, the tools that we develop and the software that we write. In fact, for example, do you remember the Hubble telescope when it was first launched? There was a problem with the mirror. We were still getting images back, but there was a problem, and so we invoked very clever programmers to try to find ways to restitch back together the image that was corrupted.
Right.
And do you know that the software that was created for that is now used for the image analysis of mammograms for the early detection of breast cancer? And so the applicability of the scholarship that comes out of astrophysics goes far beyond what is normally conveyed. I'm just echoing what you just said. Goes far beyond what is normally conveyed to the public. And in fact, I'm right now part of a study conducted by the National Academy of Sciences to explore and detail all the ways that the study of astrophysics has benefited society, not only educationally but also technologically. And so in about a year and a half, at the beginning of the decade of the new millennium, we will have a report that will discuss this. And
how does one get to be the director of the Hayden Planetarium?
I don't know if it's being in the right place at the right time, but the American Museum of Natural History, to which the Hayden is part, knew that they wanted to do something about the Hayden because it wasn't attracting the crowds it used to. In fact, its lowest attendance ever was the year before we actually closed before the renovation. And that was a year that the attendance of the rest of the museum was breaking records. And so we knew something was wrong. And about that time, I was busily doing my astrophysics research at Princeton, and I started getting some phone calls because I'd already published my books by then, and people knew that I had a public element of my life's efforts. and they knew that if you want to do the Hayden, you got to bring it both together. And so, I started to be courted for that. And initially, I was happy to simply advise the efforts that were already in progress, but ultimately, circumstances were such that they made me director, and I'm happy to do that. And by the way, I had a high school reunion recently, and I was voted having the coolest job. And I couldn't argue that. I said, yeah.
Well, it is a very cool job.
Yeah.
One of the things that comes across, you talk about teachers in our school systems needing to be passionate about what they teach.
Oh, yeah.
And part of what comes across in how you speak about all of this is your passion for it after being in
It's
this
my life.
field for many years.
It flows through my body every minute. I feel it. I see it. I think it.
Mm-hmm. Is it your recommendation that there be more taught about this in the public schools or in schools?
I think yes, that would be my recommendation, simply because it's fun and exciting. And telescopes are relatively, or binoculars are relatively inexpensive, and it was one pair of binoculars that sent me on the whole course. I mean, combined with the with trips to the Hayden, of course. But something has to trigger that spark, and it's got to be some experience that is so consuming of your mind and body, and it's got to hit you viscerally. Mm-hmm. Otherwise, it's an intellectual diversion rather than something that you commit your whole life to.
Yeah.
We just ran out of time.
Okay.
It was great to have you. We'll invite you back for part 2. We're out of time. Thanks for joining us this week. We'd love to get your comments and questions. You can reach me by calling the telephone number on your screen, or you can visit us online. Our website is www.fulani.org. This is Lenora Fulani saying take care of yourself. I'll see you next week.